Alright, so this video is about equilibrium. Equilibrium is something that, it's a certain condition that an object can be in. If you know anything about equilibrium, it's possible that you might think that only a stationary object could be in equilibrium, but in fact, either a moving object or a stationary object, both of those could be in equilibrium. So what we're going to talk about in this video is what are the conditions? What are the conditions that you need in order for something to be in equilibrium? All right, equilibrium means basically, we're about to talk about that. There we go. Here's the definition of equilibrium. The state of motion is not changing. Okay, so if it's moving, all right, if an object is moving, that means it must be at a constant velocity. Its velocity must not be changing. Okay, and if the object is stationary, it must be totally stationary and not moving at all. Okay, so the state of the motion is constant, it's not changing. All right, so an example of an object that might be moving but still in equilibrium would be an airplane. Okay, an airplane could be moving quite quickly actually, but still be in equilibrium. And another example might be, for example, this lady right here. She's practicing her balancing. I'm not sure if this is for skateboarding, possibly for surfing, but anyway, she's practicing her ability to maintain her balance. All right, so what she's got there is this special board here. It's balanced on a ball, and she's keeping her center of mass in a place. We'll talk about center of mass later, but she's keeping herself centered so that there's no motion. She's stationary. Okay, so let's talk a little bit more about equilibrium, what's involved there. All right, this is the official conditions required. All right, these are your equilibrium conditions, which is what this video is all about. All right, so the resultant force on the object, whether it's a plane or a person, the resultant force must be 0, and the resultant turning effect must also be 0. Okay? So, if we want to say that a little bit differently, we might say all forces must be balanced and the total clockwise moments must equal the total anti-clockwise moments. So as you're aware, we were just talking about moments in previous video. So if there's clockwise moments, they have to be balanced by anti-clockwise moments or counter-clockwise. Anti-clockwise is the way they say it in Britain, and since this is a British curriculum, I'm going to use that. Okay, anti-clockwise. You might be more familiar with the term counterclockwise, but it's the same thing. All right, so here we've got some rocks. I know rock balancing is something that happens a lot on beaches in the Philippines. So this stack of rocks is actually in equilibrium. It's not falling, right? It's stationary. So all of the forces of these rocks, the weight of those rocks, must be balanced by an upward force provided by this rock. Okay, so the downward force of weight of those guys has to equal the upward force that's the reactive force of that guy. All right, that's the first condition. And then the second condition is that any kind of moments, like if there's a clockwise moment there, it has to be balanced by a counterclockwise moment over here. Okay, or an anti-clockwise moment. So all of the forces must be equal and all of the moments must balance out. All right, so that's basically the equilibrium conditions. All right, so here's a concrete example. Let's take that 747 from before. It's in motion, it's flying, so it has a forward thrust. All right, it also has drag from air resistance. Okay, so there's drag on the plane, and that's going to be a backward force on the plane. All right, the plane has an upward force of lift, right? Obviously, because it's flying. So there's an upward force on the wings of the airplane, and then there's the downward force of weight of the airplane. All right. Now, if this airplane is in equilibrium, all right, its velocity is constant. It's not going up, it's not going down, it's not going sideways, it's not speeding up or slowing down. If it's at a constant velocity, then all of these things must balance out. So the forward force of thrust must equal the backward force of drag. It is not zero. The thrust is absolutely not zero in this case, okay? It's moving. There is a forward thrust, but it is equal and opposite to the backward force of drag or air resistance on the plane, okay? The upward force of lift is a real number, but it's balanced by the downward force of weight. So all of these things, this is equal and opposite to that. This guy is equal and opposite to that guy, okay? Awesome. So the airplane showed how forces have to balance out in order for equilibrium to occur. Now I want to show you a little bit about how moments have to balance out. All right, so this is a gymnast who's doing a handstand on a balance beam. Okay, so with her legs sticking out like this from her body, each of these has a weight, right? Her leg has a weight to it. And the weight, the center of mass of that thing is going to be somewhere out over here. Again, we haven't talked about center of mass yet, but the weight of her leg is going to act somewhere out over here, which is away from her body. So that's going to cause it's a downward force, and it can pivot around her body. So the downward force of weight of her leg is going to try to make her spin this way. All right. This other leg does the same thing, right? It has a downward force, and it's going to try to make her spin that way. As long as the moment of this leg and the moment of this leg are equal and opposite, she can keep herself balanced there. All right. If this leg gets to where it is providing a larger moment than this one, she's going to start to rotate that way. All right. And then she's going to have to try to counterbalance that and get herself back centered again, if she wants to stay in equilibrium, right? At some point, she'll stop being in equilibrium, and she'll go ahead and put her foot back down on the beam, probably that way, right? But in any case, as long as she is in equilibrium, all of these moments have to balance out. And of course, there's also forces here. The downward force of her weight has to be equaled by the upward force provided by the beam, right? So again, all of these forces have to balance out, and the moments have to balance out. The clockwise moments here, total clockwise, has to equal the total anti-clockwise moments in order for her to be in equilibrium. Okay, so that's an explanation of equilibrium conditions. Hope that was clear.